So now I'm just stripping the wires, the phase wire ends off. I don't know if you can see this. I'm stripping the phase wires off. I have them mounted, threaded through the holes within a segment, and I have the 60 to 50 capacitor, hertz capacitor. I have another 50 and 60 freq capacitor here to drive the system back here. I have another one here and further here of a 50-60 capacitor. I have a fan here. This is a blower, a vacuum, and suck the air down and blow it within the cockpit of the chest. It's a little bit more sticky. I don't know why it was so sticky. I abandoned it for a short time to work on other different materials. And here's the frontal of the system. And I have the permanent magnets under these brackets. I've welded it with resin. As you can see, it's just covering the parts and segments. I try to separate the segments before I do the chopping alongside the edges. So notice how the parts and segments are to look separated. It is separated, but it's like clustered together, and I routed it away from the frame, each part, and each part I mounted it away from each separate part. So this is a separate part here, and this is a separate part here, which have to be separated. The gauge difference is very wild. So there's permanent magnets with winding coil that's turned or spun around it. See, the winding coil is very protected in epoxy resin crystalline hardener. And this is the tub sink for the blower, where the blower blows this direction out of this way. To cool the frontal, which is vacuum the hot air and throw it at the front. Unfortunately, one of the pieces of the top came over here, so I have to glue and weld another one on here. This is where the permanent magnet, this is a strong, powerful magnet, and I have the winding coils around it. So it should react within the magnet field around this base, alongside it as an oscillator. So the electrical energy winding should oscillate or vibrate the magnet. Let's just lift it up now. The other side has the winding coils. Here's the boot over here that I still have and I'm working on. I added a little bit of flux wire. So notice that I put a little bit of silver wire here, iron silver wire here, and at the nose. I put a wire here and I hammered it down. Those are the eggs for the gauntlet, the actual gauntlet frontal of the nozzle. I'm going to be also doing a rubber. Here's the other one. I just finished adding the single phase rectifiers on it. I mean bridge rectifiers, and I added 4, and each of them are 12 volts. So it should enumerate 40 volts. And 400 amps actually. I'm across it and bind it in series to 400 amps. Plus I have a capacitor which is 50 to 60 hertz. Voltage. This is coil that is behind silicon carbide, and it's also have metal dressing on it. See that iron dressing? And so this is like an electromagnet glove. The repulsive part is where I'm going to be adding the permanent magnets mounted on top over the silicon carbide. Here I have also a magnet in the central in this part, in the frontal part. So that's one of those parts. Here is trying, testing out the leap frog thing on the unit. So just adding a little current to it and watching the coil bounce up and down. That's about it. And just testing how much what I need, it turns what I need for each within a magnet field. So what it's doing is actually jumping back and forth. So this helped me to determine the hop and how many turns for the hop within a magnet field, like a solenoid. So that's just giving a little bit of jump hop. So I would need an acoustic driver with about at least over 820 hertz, over 820 hertz for oscillation. And the oscillation will have to be vertical. See there, I have it going this way, so it's more like a jumper. So I could turn it over, and it will be like a solenoid vibrator, like one of those micro miniature actuators, or like a walking robot type actuator. So here, this is one of the tails which I used for one of the system. I'm just going to add this direct to the DC battery that I have. I have multiple batteries like this, wow batteries. I have a lot of power sources. But drivers I am limited to, because I would have to software drive most of the drivers and stuff like that. So I'm getting a little knack out of it. It really depends on the winding turns. This also helped me determine the winding turns which direction. So that just remember that the phase point difference, the difference towards magnetism to attack is of the attract, and there's repulsive magnetism depending on the phase wire end. And that will either enable it to jump. Both of them will not enable it to jump. Just one phase point of positive charge current to one wire. Even if you switch it, you will only switch to magnetism to magnify to stick to the magnet. And if you use the other phase wire, then it will repel from it. So the idea is to get the coils to repel from the permanent magnet presence, so that the coils may escape. Now back to this piece of armor, and the same thing with that. Like, the repulsive force must repulse away from the magnetic field in order for the coil to escape from the magnetic field. So it cannot magnetize. It's not supposed to magnetize, or it will get stuck if you have a flux. If there is a flux around the system, notice that you don't see that much of a flux, but this magnetic flux, which is right here. So because the flux will get stuck to this unit right here if it had a flux bearing around the coil. So the coil cannot have a flux bearing, or then the oscillations of electrons will oscillate within the flux bearing. And it will be kind of hard to reverse. It will stick to the surfaces of something which is alongside connected to it in the chain. So it has to be reversed. and it has to stay at its current. It can never change the phase point in. Where another one will have to be addressed as an opposing magnetic field. So without using permanent magnets, you can use another copper with a flux to oppose this magnetic emission or the wavelength. The wavelength within depth local to the surfaces will cause it to repel. But if it is a permanent magnet, local to a permanent magnet, magnetizes the orbiting electrons, would actually cause the coil of the stick if it has a flux bearing around it. The flux bearing might be magnetized and cause it to stick in place. So then you would have to switch in order to get it to oscillate and to repel away from it. But just remember that it would take time for the drainage of the magnetized material to die of magnetic energy in order to restart it, to get it to oscillate, either transonic, hypersonic, or supersonic, or sonic. It can go in different speeds depending on the oscillation, depending on the acoustic oscillation. It's either driven by acoustic crystal oscillator with different over 100,000 hertz per second, which is sectional wattage or sectional voltage. The sectional voltage could be anywhere from 300 volts or 210 volts or 240 volts, or 220 volts to 240 volts. Electromagnetic pulse phase 1, and that will enable the oscillations to rapidly oscillate and to cause a yanking force to levitation. However, just remember always is that the coil has to be more than the inertial mass, greater than in weight in turns than the inertial mass. Then the mass of the other elements that incorporates alongside of it, which is actually not the inertial, but it's the drag mass. The drag mass is actually the drag weight. So this would have to be greater. The coil turns would have to outweigh the drag weight of it. Must be way more than a magnet, each part individually, more than the nut and bolt, and the nut and bolt in enumeration of its weight towards the coil, to the coil, as opposed to the coil weight. Now the same as the irons that are alongside it. All three, the magnet, the bolt, the nut, and the frame must be less weight than the coil. And the aluminum sheet must also be less weight than the coil. So the coil turns must be greater than the mass in order to give a repulsive force away, because it's going to escape once it receives electrical energy. However, the energy that it takes to lift up in the air, to yank up and hop, is the energy that needs to be constant in order to lift the drag force into the air. My name is Jermaine Morton, and I'll be back. See you next time. Goodbye.